I am visiting cisco.com website. So it's a Cisco's official website, and I would try to showcase the content from their website itself. So if you go to Learn tab, there is a Learn tab here, and then go to Certifications, and then you can simply click on Browse All Certifications, and then keep rolling down. You should have Enterprise one. So one certification is for enterprise technologies, and for enterprise, you should have like entry level and then professional level, expert, and so and so. So just look for the professional level of certifications. So just click there, and then keep rolling down. You would see that they have got like multiple exams here. Getting started is just to go through the core exam. But then if you keep rolling down, explore exams and training. So there is an option to click there. So just click on explore exams and training and keep rolling down. Then you would have all this information. So you get started with the core exam, which is also known as Enterprise Core 1.1. 3504001 is the exam code. They have also mentioned the cost for that exam, but we are not really covering that one. All we are covering is the Cisco SD-WAN solution. So that comes under the CCNP Enterprise certification track. So under CCNP Enterprise certification, you get this exam as well called ENSDWI version 1.2. The exam code is 300415, and they also call it implementing Cisco SD-WAN solutions. So that's the training that we are going through now. We will be going through. And if you look at the exam details, like just click there and then keep rolling down. So you should have this option, view ENSDWI exam topics. So just click on that exam topics button, and then you will be displayed the whole list of topics that you need to cover during this training. So if you look at the topics, so in total you get 6 topics that we need to cover during this training. First one is architecture of Cisco SD-WAN. Second is controller deployment. Third is router deployment. Fourth is policies. Fifth is security and QoS. And sixth is management and operations, mainly focused on troubleshooting. So that's section 6 or topic number 6. So in total, you have got 6 topics. So architecture, you can also find some more details under the architecture. Like we're going to talk about the different components participating in Cisco SD-WAN architecture and their roles and responsibilities, like orchestration plane. Then you have got management plane. Then you have got control plane. Then you have got a terminology called T-log, transport locators, V-routes. Then you have got data plane. For data plane, for securing data plane, you have got IPsec tunnels, right? You have got like BFD sessions to monitor the performance of those tunnels and to monitor the liveliness of those tunnels. Then you have got multi-region fabric. Then you have got and this is all about the description. Then edge platform and capabilities, like you will have a discussion around the managed routers, like which all different types of routers we have got, and the differences between those routers, because obviously all routers, the different series of routers have got different capabilities. So we'll go through them and we'll pick few examples, and then we'll get the details about those platforms. And then you have got this sort of integration between Cisco SD-WAN and the cloud providers like AWS, Azure, as well as with few SaaS-based applications, software as service like Salesforce, Office 365, Dropbox, maybe Box. So that kind of integration is there. So that's about the section 1. Then you have got section 2, where you really start with the lab. So this section 2 is all about the controller deployment. Like in Cisco SD-WAN, we have got different types of controllers. That is one of the major difference between the Cisco's SD-WAN technology and the other vendor specific technology. Like in Cisco, you do not depend on a single controller. So they have got like Cisco has got a distributed architecture where we get different controllers with different functionalities. So we need to understand that which all different types of controllers we have got here and their roles and responsibilities, and then their deployment. So that also helps us to eliminate the single point of failure by having this distributed architecture. So Cisco is mainly focusing or is mainly utilizing distributed architecture. And yeah, that's what we will be learning here. Remember, the only lab that we're going to perform is the on-prem deployment. Although you can also deploy the controllers in cloud like AWS or Azure. That is also one of the recommended method, but due to the limitations of our labs, we're gonna host them. We're gonna host all the controllers on-prem only. So this is what we will be doing here. And in fact, in content also, they have got this on-prem deployment only. So that's what we will be doing. And then router deployment. So over here, you're gonna learn about like how to onboard routers. So the onboarding of the routers will be covered over here, but not only onboarding, but also the configuration of those routers using the templates. So using templates, you're going to learn about that how to configure, like how to terminate circuits like internet circuit or MPLS circuit, what is TLOC extension, then how dynamic tunnels are coming up, underlay connections for a router, overlay connections for a router. So we need to understand that what is the meaning of underlay and overlay. And I do not really think that underlay and overlay, these terminologies are new terminology for any of you, because this overlay and underlay is been there in networking since long time. Like even if you work on GMVPN or maybe GRE tunnel or maybe just an IPsec tunnel, you have to configure the underlay as well as the overlay. So this underlay overlay terminology is not something really new for you. I'll explain them later, but I'm just giving you an idea that which all topics you're going to cover. And then
Yeah,
OMP,
it's like
then
a
logs.
yeah, it's like a physical path and logical path.
So yeah, exactly. So underlay is always the physical path, you can say that, and overlay is kind of like logical path or virtual networking, like
Yeah.
how you implemented IPsec tunnels in past. So
Mhm.
IPsec tunnel was always an overlay, whereas IPsec tunnel was mostly implemented on top of either MPLS connection or maybe over an internet connection, right?
Internet
So
connections. Yeah.
that was an example of the underlay connection. Then you have got OMP protocol, that is a totally new and a different protocol than what you have learned so far. Like probably you must have learned OSPF, you must have learned BGP, ISIS, or maybe many more. There are many dynamic routing protocols, but Cisco is having their own Cisco proprietary protocol, which is called OMP, and this OMP is very essential for the Cisco SD-WAN.
Is there any open standard protocol also
No,
equivalent to OMP?
no. There is nothing like open standard so far for the SD-WAN technology from
Okay.
any vendor. So all the vendors, like for SD-WAN, we do not only have Cisco, right? We have got so many different vendors for SD-WAN technology. Like we have got Cisco, but apart from Cisco, we have got FortiGate and
Juniper,
Fortinet.
Juniper,
Then we
Palo
have got
Alto, everyone
Juniper, we
started
have
giving.
got Palo Alto, then we have got even Zscaler now, and then we have got Versa, we have got Nokia, we have got probably many other,
VeloCloud.
Velo Cloud, and many more. So all of them are having their own technology for SD-WAN. So there is nothing like open source as of now. Maybe in future something like open source can come up, but as of today, while I'm speaking with you, there is nothing like open source. So this OMP is Cisco proprietary, and then you have got TLOCs, the configuration of TLOC, and then you have got VRRP, OSPF. So in Cisco SD-WAN, the beauty of this solution is that you still have support for the traditional protocols like VRRP, for OSPF, and then for BGP, and then for EIGRP. So even if you are using like BGP in data centers, so in SD-WAN you can still leverage that. We can still leverage BGP, we can still leverage EIGRP, we can leverage OSPF. So that's a good thing about this Cisco SD-WAN. Like if you look at the other SD-WAN providers, they are mainly focusing on branch side, and they do not really focus on like dynamic routing. I'm not saying that they do not support, they do, but they have got some limitations as well at the same time. But in Cisco, they do not have any kind of like limitation. You can enable any of the traditional dynamic routing protocol if required, when required. And then multicast routing is also supported in Cisco SD-WAN. And of course, you have got the templates, like you can create configuration groups, feature profiles, workflows. So that's something that we're going to cover during this training. And then fourth is policies. Remember that this is one of the, I would say, most important part of the Cisco SD-WAN, because the traffic flow between the branches and of course data center will be depending upon that how and which type of policies you constructed. So the traffic flow between the remote sites will completely depend upon the policies. Like if you look at the default behavior of the Cisco SD-WAN, that provides you full mesh connectivity between the remote sites. Like as soon as you bring up your remote sites and data center, all gets an IPsec tunnel established automatically between each other. So that's how you get full mesh connectivity between all of the sites. But then using policies, you can always modify that. Like you want to convert your connectivity into like hub and spoke or maybe partial mesh. So it's up to you how you want to make that happen or how you want to have connectivity between the remote sites. So for that purpose, the policies becomes really critical. So you would get to know that how to implement control plane policies. So like mainly this control plane policies to filter your routes, and then data plane policies is more like policy based routing that we used to implement traditionally on routers, right? I don't know how many of you have worked on the policy based routing, but these data policies are kind of like the advanced version of those policy based routing. So whenever you have a requirement where you do not want to modify the routing table, but you want to steer the traffic flow. So if you want to steer the traffic flow without modifying the routing table, then you would have to go for the data policies.
So, sorry to interrupt, Saurabh.
Uh-huh.
Is that policy-based routing to support the applications?
Yeah, absolutely. As I said, that earlier we had policy-based routing, but here this data policy is an advanced version of that policy-based routing. Not only you can match your data based on source IP and destination IP, but also you can match your data based on applications. The VPN segmentation is one of, it was a kind of unique feature that Cisco was offering in past, but now I see that many other vendors have also started to support like kind of same solution. But in the beginning, like if I talk about like 2 years back or 3 years back, Cisco had it as a unique feature, one of their unique feature, the VPN segmentation. So this VPN segmentation basically that helps customers to have like different type of networks in a single infrastructure. Like for an example, you have got a corporate network, and then also you have got a PCI compliant or maybe HIPAA compliant for a healthcare kind of customer. So if you have got a healthcare customer, then you would have a HIPAA type of network. Not typo, but I would say that they will have to match their network with a few compliances if they are into healthcare type of business. And if they are into banking sector, then they have to follow the PCI compliance. So all their POS machines must have a separate network, and that comes under the PCI compliance. So to fulfill the requirement of the compliances like PCI or HIPAA, so sometimes you may have to segregate your corporate network from those specific compliant networks. Then segmentation becomes really important. So earlier, like traditionally, we were using VRFs, virtual router and forwarding on Cisco routers. Because see, I'm not taking an example of the firewalls because we are not going through the security. We are not covering any of the security related topics here. We all are covering here routing. So I'm taking an example of the routers only. So on routers, the segmentation was possible even in past, but using VR, virtual router and forwarding. And then the topology. So as I said, the default behavior of the Cisco SD-WAN is to build like kind of full mesh connectivity by default, but then you can change it to like hub and spoke or partial mesh, like that. And then as I told you, so this time you're going to have the application aware route. So you can match your data based on applications, and then you can steer your traffic based on the requirement. And the DIA, direct internet access. So like in a branch, if you have got the internet circuit terminated, and obviously with SD-WAN, you would have that internet circuit terminated. With few exceptions, there will be some customers where you would not find any kind of internet connectivity at branch location. Probably they will be using just MPLS. But in most cases, you would have the internet circuit terminated at each remote location, at each remote branch. Just in case if you have got a requirement that for Office 365 or maybe for Dropbox, you want to send your traffic directly over the internet. You don't want to backhaul your traffic into DC. Why? Because backhauling all internet traffic via data center might cause some additional latency, and that additional latency might cause some poor performance for few SaaS-based applications like Office 365 or Dropbox or Box or Salesforce, etc., etc. So to fix those issues, you might want to configure direct internet access, where if you have got internet circuit terminated at remote branch, and if your lane users are accessing Office 365, let's say, while accessing Office 365, then their traffic will go directly over to the internet, will not backhauled into the data center. That's kind of like one of the use case of the DIA. The next is security and quality of service. So if you look at here, it has got all the security related stuff like how to apply application aware enterprise firewall. So I don't know how many of you already have worked on these on-based firewalls. But you all must have heard that Cisco routers used to support these on-based firewall. Even today, if you have got a Cisco routers and you want to enable the capability of the firewall, you go ahead and enable this on-based firewall. It's not a full-fledged firewall, but yes, after all, it is a stateful firewall, and you can easily perform kind of like layer 4 filtering using that zone-based firewall. And in few cases, in some cases, you can also work around the applications as well. And that's what exactly they brought here in SD-WAN as well. So a router supporting Cisco SD-WAN in Cisco will also have a support for the application aware firewall. So where you can say that, hey, I wanna drop the data for Facebook, I wanna drop data YouTube or many other applications. So you can create your application list, and then you can drop the data for those applications. And of course, you can say that, okay, whether you need to drop the data or you need to inspect the data, because it has got the firewall functionality over here. So you have got firewall on your router, and then you have got IPS URL filtering, AMP, which is advanced malware protection, and then you have got SSL TLS proxy. Remember that these features are supported by Cisco SD-WAN here when it comes to the security. IPS URL filtering, AMP, and that's what makes it next gen firewall, because these all are the next gen features, right? Next gen firewall features. So a Cisco router in Cisco SD-WAN will have support for all these security features, but keep one thing in your mind that ideally we do not enable those features on Cisco routers. Why? Because first thing is first, that if you want to enable those security features on your Cisco routers, then you will have to make sure that you are purchasing routers from Cisco with some additional hardware resources, like with additional CPU cores, with additional memory, with additional boot flash. Then only those features like IPS, URL filtering, SSL proxy will be supported. For application aware firewall, you don't require any kind of additional hardware resources on your Cisco routers. Like to enable application aware firewall, you don't require additional CPU cores or kind of like memory or boot flash, nothing like that. But to enable IPS, URL filtering, AMP, SSL, TLS proxy, either you are enabling all those features or you are enabling any one of them, it doesn't matter. In all cases, you would require to install an additional software, an additional application on your router. So to support these security features like IPS, URL filtering, you would require to install a security app on your router. And to install that security app on your router, you need those additional CPU cores, memory, and boot flash, of course. So it's not that easy. It's not that straightforward. So if you are having a discussion with the customer about the solution, then you must ask them that if they are really looking for these features, then the cost of the routers will also go higher, because you have to purchase the routers with additional resources. I'll go through the Cisco's website as well, and then I will explain that how many additional CPU cores and memory would be required in case of enabling security features like IPS, URL filtering, AMP, SSL proxy. The Trust SAC is also there, so you can also implement Trust SAC on Cisco routers. The cloud security integration, like you can integrate your Cisco SD-WAN with Cisco Umbrella, and not only with Cisco Umbrella, but also with Zscaler, and not only just Zscaler, but also maybe Palo Alto Prism, or maybe Cloudflare if they are providing you the SIG services, or maybe there are many others. So if you have got some cloud-based secure internet gateway providers, you can integrate your Cisco SD-WAN with them. But integration with Cisco Umbrella and Zscaler is quite easy, because they have got some specific options available for Cisco Umbrella and Zscaler. It is easy for a customer to integrate their Cisco SD-WAN with Cisco Umbrella and Zscaler to provide secure internet gateway services. Then QoS, obviously, as you know, that QoS has been really important and important part whenever we talk about any network. So obviously in SD-WAN also you need to define your priorities, that this traffic is the most critical one. Then you must provide preferences to those to that traffic accordingly. So QoS is there, where you're going to learn about queuing, shaping, policy, all that stuff. Then you have got quality of experience as well, where you learn that how to perform TCP optimization, packet duplication, forwarding, error correction, fact. So it's all about the optimization. Although the optimization technique supported by Cisco SD-WAN is not as good as I believe VeloCloud supports. VeloCloud has got, I mean, I do not really have an extensive experience over VeloCloud, but what I can recall from there is like they have pretty much good features when it comes to the optimization. So that's all about the topic number 5. And then 6 is about management and operations. So
Saurabh, this TCP optimization, is it equivalent to that what Riverbed used to provide
correct,
WAN
correct,
optimization?
correct. But it's not that much extensive. I mean, they
Okay,
have got Cisco has got a pretty much basic feature.
okay. And
And
one
I
more
believe
question.
that when optimization supported by Riverbed, they inherited all those features into Velo Cloud, if I'm not wrong, actually. So
Okay,
Riverbed is not required anymore.
okay. Yeah, most of the companies are not using Riverbed nowadays. Regarding the certification, if one has to do CCNP, so is this
Correct.
exam related? Is this exam equivalent to CCNP, or for
No.
CCNP one has to do
If you want to
CCNP
become
Encore?
CCNP, yeah, if you want to become CCNP in SD-WAN, then first you have to go through the core exam and then this SD-WAN is specific. First, you go through the core, obtain that certification, and then obtain this SD-WAN certification, and that's how you become CCNP SD-WAN.
Okay.
Yeah,
So this concentration exams, basically, I saw when you were browsing through, there were many concentration exams. This
correct,
is one of them.
correct, correct. So if you I go back to the CCNP enterprise certification track, right? You would see that first of all they have got an core exam, right? This is mandatory exam, and then you have got this concentration exam, and you need to attempt at least one, right?
Okay. And if one has to do CCI enterprise, then the theoretical part, CCNP Encore is sufficient, right?
Correct.
And then one can go through the lab directly.
Yes.
Sir, for lab, what will be the exposure of the SD-WAN, if you can help?
So for lab examination, for CCIE lab examination, you do not have that many tasks as of today, right? Uh, from the SD. There are some tasks, but so easy. You don't really have to worry about that. You're gonna learn much more SD-WAN techniques, much more SD-WAN things which are required, as compared to the requirement that you have for the lab examination. So you don't really have to worry. They are asking pretty much basic questions in exam as of today. Even if you go back, so they do not have any exam specific to the SDA only, but yes, they have got SDA included in other exam. That's how they have shaped their certification tracks or certifications as of today. Tomorrow they might add a specific certification for SD as well, but today they don't have anything like that.
Sir, how long is this course and gonna be the our SD1?
Ideally,
Yes,
I'm not talking about the SDA because I'm just covering the SD-WAN during this
the
time.
SD1. Yeah, sorry.
Yeah, it should take like around 5 to 6 weeks maximum.
Oh, okay.
Yeah,
So we have like
a month or so.
4 classes per week, right?
Correct. So there
Oh,
will be
okay.
4 classes per week from Monday to Thursday, and
For 6 weeks.
let's say, yeah, we have started this today. Let's say I would say this is first week, second, third. So 3 weeks we have in this current month, and then at
Mhm.
least 3 weeks I'll be taking during month of December.
The topics you discussed about is like explained. So we're gonna go through all those topics, right?
Correct.
Thank
Yeah. So if anybody has any questions so far, please do not hesitate to ask.
Yes, Saurabh, but this 6 weeks you're telling that includes the lab portion as well, or lab is excluded?
Which lab you're
The,
talking about?
the
CCIE
labs.
lab,
No, no, no. The labs
the
for
labs for SD-WAN? Yes, that
SDN
also includes the labs.
includes the
Because
lab.
while I'm performing here or while explaining SD-WAN, I'll have to perform the labs at the same time. Okay, so now let me ask you a couple of questions now. SDN, software defined networking. What do you mean by SDN? Can anyone explain?
Basically, all the management part and the control part is managed through a single software.
A single controller in short.
Yes, yes.
So that's SDN, right? Software defined networking. So this software defined networking is not a new terminology. It's not really something new for us. Like me personally, I've been hearing this word since I would say 2012, somewhere around 2012, that SDN is coming in, SDN is coming in, software defined networking is coming in. What is the meaning of SDN? right? Software defined networking, which means that like what we do is, like if I take an example, let's say there is a corporate network. I'll take one example. Let's say there is a DC1 and then there is a DC2. There is an ISP. There is MPLS. Maybe we have got an internet circuit in both DCs. We have got MPLS in both DCs. If you had a remote office, which is like branch 1, branch 2, branch 3, maybe branch 4. And let's assume that this is not just an ISP. Let's say this is MPLS itself. PLS provider 1 and this is provider number 2. Then ISP was there, connection in DC1. A different internet connection in DC2, maybe from a different ISP. And then in branches, you had MPLS from each provider. Like this. In most cases, we had this type of connectivity. Like that was kind of like a solution that most customers had. If they had like multiple DCs, if they were having just one single DC, then they had single DC. If they had more than two DCs, then you can add. You can keep on adding multiple data centers, but the branches were connected to data center using MPLS, and then internet circuit was terminated in data centers only, and all your traffic from branch offices, from remote branches, was backhauled into data center. And if any of the branch user needed to have access internet, then they were again backhauled into DC, and from DC they were going to internet. That's how they all had access to the internet as well as to their private applications hosted in data centers. I mean, that was the most common one, common diagram for or common architecture for most customers. Now the problem was like everything was going perfectly fine, but we had like as a customer we had different type of problems. So let me ask you one, couple of things here. So let's say you had 1000 branches for a customer. If you had 1000 branches and where you had maybe 1200 routers, because some of the branches were dual CPE and some of them were single CPE branches. Now, based on single CPE and dual CPE, you had number of routers. So I'm just taking the approximate number of routers. And let's say you were using SolarWind for network monitoring. You also had some other solutions, maybe some other AlgoSac or something like that. And for those type of solutions to work, you needed SNMP string. So SNMP string becomes really critical, really important for any customer, because using SNMP community, you can talk to your routers. Right? So it depends like whether you have created read-only read-only community string or read-write community string. But the SNMP communities are really important. Now, let's say that one of the SNMP community was compromised. And now you needed to update that SNMP community across all 1200 routers. Across all 1200 routers. So now you tell me that how much time you would take as a lead, as a manager. Let's say you are managing your team. So how much time you going to ask your management that you require to update this SNMP community? Because this needs to be updated because it has already compromised. So if it has compromised, then that needs to be updated. Just imagine. It's a small task, but just imagine that how much time you require.
But if we are doing manually, it will take too much time.
Yeah, that's
But
how you were doing it. I mean,
but if
traditionally.
we are using SNMP NCM tool,
Uh-huh.
we are pushing, then not hardly half an hour it will take.
But again, using that tool also, you need one community string which is already in place. That's how that tool will talk to your devices, Yoginder.
Is it? But if we are using SNMP NCM, we have to select all the 1200 devices in a one go, and we have to
Now,
push the
I
configuration.
get that, but are you trying to understand my point here? Like you already have an existing community. Using that, your tool will be talking to your devices. That's the point. So you can change. I'm not denying that, but again, you need one community that you don't want to change. And using that community, your tool will be talking to those 1200 computers. So point is that if you need to update that and you are doing it manually, just imagine that how much time it will take. And not only that, I'm giving you a few examples here. So that was one of the common issues that we had. Think about the logging server. The logging server IP got changed. The NTP server IP got changed. AAA server IP address got changed. I mean, obviously those things doesn't get changed quite often, but let's say you had that kind of requirement. Maybe you are doing a change. Now let's talk about the change. And let's say you're changing the BGP. across the organization, the management decided that MPLS 1, let's say this is from Tata, and the MPLS 2 is, let's say, from who? Airtel. Let's say Tata was your primary and Airtel was secondary across all your remote offices. But now your management has asked you to change it. Now your management wants to configure Airtel circuit as a primary circuit and then Tata as secondary across all the remote sites. Now, since all routers at remote branches, they're running their own control plane. They have got their individual control plane. So you have to go to each and every router and you have to modify the BGP policy, whatever policy you had in place. You need to modify that so that your primary circuit can become Airtel now and secondary is Tata. So you need to push that configuration across all routers manually now. I'm not talking about any kind of, like scripting or something like that, because when you start using scripting and that becomes SDN then, because again, if you're using a scripting, which means that you're using a controller, and if you're using a controller, then it becomes SDN, software defined networking. So I'm not talking about the SDN. I'm talking about the pain points that you had. Now, apart from that, if you're touching, let's say you're touching 100 devices in a day, and you had a change on 100 devices. In most organizations, I'm taking a generic example here. In most organizations, you would require to take their config backup first. So across all 100 devices, first you need to take their config backup, and in fact there is a procedure, right, that you need to write the config first and then take the backup. And if you're doing that manually, so just imagine that how long your change window would be, maybe 12 hours, maybe more than that. And then how many people would require, let's say you have got a team of 20 people, then each person will have to make changes at least on 5 devices. So across all 5 routers, every engineer would require to write the config, then to take the config backup and then make the changes, validate them. If changes went into a wrong way, then revert them. If not, then write config and then again take the backup. And if there are no 20 people, let's say you had only 5 people working in that shift, then each person will have to work on 20 devices. And if there are just 2 person, then each person would require to work on 50 devices. And if there is just one, just imagine how difficult it would be. So you need more manpower to manage your changes, or you needed that. I'm talking about the traditional stuff, and you just needed to modify some BGP configuration, some policy, so that you could direct your traffic through, you could change your primary circuit from Tata to Airtel. So that was another challenge. Then I'll take one more example here. Let's say you had a branch somewhere at remote location where you had this MPLS connectivity, and then on WAN facing interfaces you had some ACL on WAN facing interfaces, let's say. And sometimes, some accidental changes also happens. So some accidental changes happen to this WAN ACL, like there was an ACL applied on WAN facing interfaces. Some changes occurred to that ACL unknowingly or accidentally by the engineer. And then the engineer was sitting maybe in headquarters. Engineer is not sitting here in local branch. And then that engineer lost access to this router. How they could fix that problem then? There was no way to come out from that situation until unless you ask someone in branch to reboot that router if they had access to that rack. And let's say rack was locked, then they don't have access. Then you need someone, like field engineer, to visit that place and to reboot the router. Right? I mean, you had those kind of challenges, and I have gone through those situations during past 15 years. So that was another challenge, that once you locked your router, then it was locked, and you needed then field engineer to fix that problem. Sometimes, like, obviously it depends again customer to customer. If customer had no locked rack, then probably you could ask someone in branch to reboot that router. But in most cases you needed the field engineer. So that was another challenge that you had. The other challenge was, now the biggest challenge, these all are the small challenges that I have spoken about. The biggest challenge that we had was that now applications are moving to cloud, and applications becoming more heavier than before. Like, there are applications which would require, let's say, at least 2 Mbps of the bandwidth or 1 Mbps of the bandwidth. Whereas in branch, let's say you had MPLS connection, one for, let's say, 1 Mbps. The other one is for maybe the backup. Backup was for just 512 kbps, let's say. Now, how you could access those applications if your applications are heavier? So you need to increase your MPLS bandwidth. But if you increase your MPLS bandwidth, that would also increase the cost, the recurring cost. The recurring cost will also get increased at the same time. And then let's say now you talk about the Office 365, right? So Office 365 cannot like, it will not really work really good with even 5 Mbps. I'm not talking about just one Office 365, one single application. There are many other applications. So point is that we needed more bandwidth. Now, if you are depending upon the MPLS, then the cost will go higher and higher and higher. And at some point, probably you might get a notification from the provider that we can provide you maximum 10 Mbps of the MPLS bandwidth in this area, because we do not have the availability for greater than 10 Mbps bandwidth in that area. We do not have the circuit availability. So due to some technical constraints, you might have that kind of blockage as well. But when it comes to the broadband connection, the internet connection in the same area, let's say the provider is offering like 100 Mbps or maybe 1 Gbps, and which is cheaper than MPLS. Now, can we have that kind of broadband connection? Of course, no. Why? Because then how are we going to connect to the DC then? So in that situation, then what you were doing is like you were taking the internet circuit, you bought that internet circuit, terminated in the branch, and then probably you were configuring IPsec tunnel manually, or you were configuring the DMVPN if it was a Cisco router. Like in Cisco, we already had the DMVPN, but that required so much of manual efforts. And that's how the SDN, like people started thinking of the SDN. Like, okay, instead of doing configurations manually, instead of making these changes manually, can we have some sort of software? Can we have some sort of controller which could help network engineers to make the configuration changes across the routers, or to minimize the manual efforts? Like, just imagine that you needed to configure the IPsec tunnel. Now, I don't know how many of you have an experience of configuring IPsec tunnel on a Cisco router, but if somebody has done that, then you must remember that how many commands and how many, like that was a quite long script, like phase 1 configuration, phase 2 configuration, then crypto map, or so and so. And even in sometimes, because MPLS MPLS is not a secure connection. It's a private connection, but it is not 100% secure because traffic is still going through your provider's net. So you can't be 100% secure. So even I have seen customers that they had IPsec configured on top of the IPLS itself, and that was done manually. So it was a manual effort altogether, and that was huge. You needed more resources to perform all those tasks, to manage your network, to make the changes across the routers. You needed a greater a big team to manage large networks, like where customer had maybe 500 branches or 1,000 branches, or maybe more than that. You needed larger teams. So that's where people started thinking of this SDN, software defined network. I hope that everybody got this background, that I tried my level best to give you some background knowledge that what sort of pain points we had and why this SDN came into the picture. So to fix all these issues that I have discussed so far, this SDN came into the picture. So in SDN, what you have got is a kind of like controller. So you get a controller, and from that controller, you make the configuration changes across your network devices. Now, whether you use the Python scripting, or you use the shell scripting, you use the like SD-WAN thing, or whatever you are using, ultimately you're using a controller, and from there you are pushing the configuration. So SDN is nothing, but it is a controller-based networking. And trust me, Cisco was quite behind than anybody else in this world when it comes to the SDN, software-defined networking. Initially, Cisco was not really focusing on this SDN thing, but then Silver Peak, and then Velo Cloud, and then some other vendors, CloudGenix, all these providers came into the market. Like Versa came in, then later Nokia came in, and Cisco was still like looking at the people, okay, what they are doing, right? But then everybody else captured the market. Viptela was also there along with this CloudGenix and all that.
Yeah,
So
for
then,
the
yes.
automation, I would just want to give an example. So for the example of SDN, I'm using Cisco DNA Center. So
Yep.
we have like 200 plus edge devices, which is located in libraries, community centers, and all over the county where I work for. So there was a back, if you remember, from the Cisco announced that we have to remove HTTP and HTTPS as soon as possible in the 17.56 lower version of the images. So what I did is I wrote a script, a template, and then I just deployed the template. It went through like 200 plus devices and remove HTTP and HTTPS from the devices within like 10
In
minutes.
a
Yeah.
minute or so, in a couple of
Yeah,
minutes, I
yeah.
would say.
I got like 50 devices failed, and I redid it, and they went through again. Like it took
Right.
like 10 minutes to remove everything.
Yep.
So Cisco is also using like that Cisco DNA Center. They changed the name to Catalyst Center now, and that's very very good if someone is like kind of
That's where I'm coming now. So initially,
yeah, I can
I'm glad
recommend
that,
that further.
yeah.
Yeah.
Initially, they didn't have anything like DNA center. They didn't had anything like SD-WAN, nothing like that, right? They
Mhm.
were doing everything manually. They had some controllers, centralized controller, but that was not like a full. That was not supporting a full kind of automation. Like for Cisco ASs, they got what to call them, CMA, something like that. I don't remember
Yeah.
that name exactly. But for Cisco ASs, they had some centralized controller. From there, we could manage the policies for multiple firewalls from the same location. Then they had Cisco Prime for their wireless infrastructure, right?
Yeah.
And then later they came up with ACI thing, and that's where exactly they got started off with this SDN thing when they
SD.
launched this ACI, and then they acquired Whiptail. That's where SD-WAN thing, got started with Cisco. So there was a Whiptail vendor, and in 2017 they acquired the Viptela. So there was a Viptela SD-WAN, and that became Cisco SD-WAN in 2017. So if you look at the Cisco SD-WAN technology, originally it's not developed by the Cisco itself. They acquired it from Viptela. Actually, I mean, they acquired the Viptela itself. So Viptela became part of Cisco, and that's how the Cisco SD-WAN got started. So in 2017, Cisco acquired Viptela, and that's how the Cisco SD-WAN thing got started. As I told you, like I started about the Silver Peak and then Velo Cloud in 2012. But then after 5 years, Cisco acquired Viptela, and that's how the Cisco SD-WAN. And initially, people were really afraid that whether the solution is going to work for the customer or not. And initially, Cisco really had so many challenges with their SD-WAN solution, but now it's quite reliable. It's quite reliable, and I see that a lot of customers are moving on to Cisco SD-WAN. Of course, there are customers who are moving away from the Cisco SD-WAN, but for those customers, Cisco has got another solution, right, which is called Meraki SD-WAN. So basically, when it comes to the SD-WAN thing, Cisco is currently offering two different solutions for their customer. One is called Cisco SD-WAN, the other one is called Meraki SD. I mean, what Cisco says is that if customer cannot really spend huge money, like if they want a cheap solution, money wise, I'm not saying that solution is cheap. I'm saying from the investment perspective, if customer does not want to spend that much money and they want to upgrade, they want to switch on to the SD-WAN thing, then they offer the Meraki SD-WAN. The Cisco is offering them Meraki SD-WAN because Meraki SD-WAN, the cost of the Meraki SD-WAN is quite lower than the Cisco's SD-WAN, where we use the Cisco routers. So they have got Meraki SD-WAN, then they also have got the Cisco SD-WAN. But during this course, we're gonna focus only on the Cisco's SD-WAN. We are not going to focus on Meraki SD-WAN. And you must have observed that when I went through that course outline, there was nothing like Meraki. As of today, Cisco has not included the Meraki SD-WAN into any of their training content. So that's the reason that I'm not going to discuss anything about the Cisco's Meraki SD-WAN. But yes, Cisco SD-WAN, now they have renamed it. The Cisco SD-WAN has been renamed it as a Catalyst SD-WAN. Now it's Catalyst SD-WAN. So, or you can call it like Cisco Catalyst SD-WAN, something like that. So that's how the story or the whole story got started. So basically, Cisco SD-WAN got started off in 2017, and initially they called it Viptela SD-WAN, Cisco Viptela SD-WAN. Then they started calling it just Cisco SD-WAN, and then finally they renamed it now as Catalyst SD-WAN. And yeah, I mean that's all I wanted to discuss with you, that why the SD-WAN was needed, which all pain points, not all, but like I've just discussed like common pain points with you, that why this SD-WAN thing was required. As I told you, like traditionally when we had internet circuits in branches, we needed to depend upon the manual IPsec tunnel configurations or maybe DMVPN configurations. But with SD-WAN, what happens is that as soon as the WAN connection comes up, the device comes up, the IPsec tunnel will get built automatically. Like you don't require to configure the IPsec tunnel manually. That comes up automatically. There is a predefined configuration that takes place, and then IPsec tunnel between the remote sites over an internet circuit comes up dynamically. So you don't really require the MPLS connectivity as an underlay between the remote sites or between remote sites and the data center. You don't really have to have dependency over the MPLS. You can simply have the internet connection, and that too a broadband connection. Like if you do not have the lease line available, because the leased internet leased lines are way expensive than the broadband connections. So you can simply depend upon the broadband connection in SD-WAN. So whether you are having the Cisco SD-WAN or Silver Peak or Velo Cloud or whichever SD-WAN you have got, you can simply depend upon the broadband connectivity. Like if I have got a broadband connection at my home, 400 Mbps, I can also install the SD-WAN router, and then I can also become the part of the corporate network easily. That's why, like more and more customers are adopting the SD-WAN, and they are simply removing the MPLS from their WAN side, and they are moving away from MPLS to the internet circuit nowadays. Because for internet circuit, you get 1 Gbps of the bandwidth easily, and it's easily available. It's more cheaper than the MPLS bandwidth. So I'm not saying that the MPLS has gone away completely. It's not. Still, you can find so many customers using MPLS only. I have seen them, right? And especially in banking sectors, you would see that there are few banks who are not really trusting the internet, right? So they are still using MPLS for their branches to connect them to the data centers. But not only they have MPLS, but also they have got the internet at branches for few requirements or to meet few requirements. But they are not fully moved away from MPLS to the internet. But there are many other customers, right? Because in this world, there are not only banking customers, but also we have got so many other different types of customers. Like you have got healthcare, you have got transportation, you have got government services, you have got so many other different types of customers, where you would see that people are, they have started trusting internet now for the SD-WAN. Because in SD-WAN, ultimately your traffic is secured by the IPsec tunnel. Although you are using broadband, let's say, or maybe internet lease line, but the IPsec tunnel is coming up automatically between the remote side. If your traffic is going from one branch to another branch, it's secured by the IPsec tunnel. So I'll discuss that later. But yeah, I just wanted to give you the background that why SD-WAN was needed, was required. So it is not to kill anybody's job. Basically, SD-WAN was there to help us, to help the network engineers to do their job in more efficient way, quickly, and more accuracy.
To
That
reduce the
was,
configuration overhead, basically.
yeah, exactly. And if I'm saying that, okay, it is not affecting the number of resources required in a team, I may be wrong. Why? Because it is definitely affecting. Because let's say you are having a controller. Earlier you had a team of 20 people to manage maybe 500 branches. Now, management might think that since you have the centralized controller and you can push the configuration from that centralized controller across the network, across the infrastructure, then they might think of that instead of having 20 people, let's go with 10 people in the team. But then at same time, the IT infrastructure is also increasing. Like more and more countries are adopting IT, right? And you are getting more and more, like companies are getting more and more contracts, right? And that's where they need more engineers. But yes, if you talk about from a project standpoint, like in a project where you needed like maybe 50 people to manage, now after adopting automation and this SDN thing, controller based networking, you might require 20-25 people. So you can easily cut off the 50% of your workforce, right, from a project. But since the number of projects are increasing, so it's not really affecting the jobs, I would say that. If anybody has any more questions or concerns so far, please go ahead and do not hesitate to ask. If you do not have any questions, then that's all from the introduction point of view, because that was all introduction, right? That I gave you today, like what we are going to cover, how we are going to cover, right? Why SD-WAN came in, right? What is SDN? So in Cisco, let me tell you that if you talk about the Cisco particularly, as of today in Cisco, if you talk about the SDN, so you have got SD-WAN that is from Cisco as well as Meraki. So there are two different products when it comes to SD-WAN. And you have got SDA, which is for enterprise switching and wireless. And this is for enterprise networking, I would say. The SD-WAN is also for the enterprise networking, but for the WAN side. And then you have got Cisco ACI, and that is for DC. So if you look at here, you get end-to-end solution. Like in Cisco, when it comes to the SDN, they are providing you the end-to-end solution. So for data centers, they have got ACI, and then for their branches, because in branches you would have like Catalyst switches, and then you would have the access points, and then you would have Catalyst wireless line controllers, right? You would have identity service engine, right? You might have 1000 eyes and all that. So all that can be integrated with SDA. And then to interconnect your branches with the, to interconnect all your remote branches together as well as with the data center, you have got the SD. So you have got like a full solution. Like in DC, you run ACI. Within branches, you run SDA. And then to interconnect all your branches and data center together, implement SD-WAN, right? So Cisco is providing a complete end-to-end solution when it comes to the SDN. Any question so far?
Would you mind, sir, explaining the SDA a little bit? Yes.
SDA, basically in this, you are using a controller called DNA Center. DNA Center. There is a controller. Using that controller, you can manage all your switches, Catalyst switches. I'm not talking about the Nexus switches. You can't manage your Nexus switches from Catalyst Center or DNA Center, because this DNA Center has been renamed as Catalyst Center nowadays. So from this centralized controller, you can manage all your switches. So when I say you can manage all your switches, which means that you can make the configuration on your switches. Like for an example, you wanted to create VLANs, or you wanted to create SVIs, you wanted to enable FHRP or dynamic routing protocol, you can do that using templates. And apart from that, you can also integrate your switches with AAA, like maybe you want to enable TACX for admin authentication, or maybe you want to enable
I've done
.1x
implemented all those. When you said DNA Center, I got the example, sir.
Yeah. So
I'm currently running DNA in my network, and also Nexus Dashboard is the new project.
Yep, Nexus Dashboard is again altogether only for Nexus switches, not for the Catalyst one. So,
sir, Ravi here. So I have one question about the SDN. I'm audible?
Yeah, you are.
Okay, sir. There is part. ISC is part of SDN, or which type of part? Is it the ACI part? SDN part?
ISC is not a part of any of these SDN thing. Actually, ISE is for endpoint security. I mean, this is for .1x authentication. Like you don't. I mean, it's part of the zero trust, I would say. The ISE, Identity Service Engine, is part of the zero trust. And zero trust is achieved by the help of, like, obviously you connect your devices to either wireless network or wired network. So when it comes to the wired network, then you have got Catalyst switches. And when it comes to the wireless, then it, your users have to come through the access point and then WLC. So at that time, you
part of the enterprises network. Then.
Correct. The ISC is part of the enterprise zero trust. So you get so many things there, right? ISE, and then you integrate ISE because see, for ISE to work, you have to make the configuration on your Catalyst switches as well as your WLC. If you're doing it manually, then it takes really long time, right? Because if you do it manually across, let's say you have got 500 switches or more than that, then you have to do it manually, and the configuration is quite lengthy, right? It's a long script that you need to make or you need to execute on your switches. By the help of DNA Center, it's just a couple of clicks. Let's say you got 100 switches, 500 switches. You need to integrate AAA ICE with all switches for maybe admin authentication, or maybe you need it .1x authentication in place. So it's a matter of couple of clicks. Just integrate ISC with DNA Center and just deploy your devices, and that's it. So DNA Center is not just for the purpose of automation. It is also providing you the assurance services. So, I mean, let's not go into that way. Let's focus more on SD-WAN, software defined wide area networking, right? So in SD-WAN, we have got two different solutions from Cisco as of today, the Catalyst SD-WAN and the Meraki SD-WAN. We are not going to cover anything from the Meraki SD-WAN. Our focus will be only on the Cisco's SD-WAN, or you can also call it Catalyst SD-WAN. And yeah, of course, if there is a SD-WAN thing, then there must be controllers, and that's what we will be discussed tomorrow, where I'll be discussing about the architecture of the Cisco SD-WAN completely, where we would learn that which all different components we have got in Cisco SD-WAN. Like, I don't know how many of you have some familiarity with the Cisco SD-WAN, but yes, here you have got like vManage. Earlier, we used to call it vManage, but now they have renamed it as a Catalyst Manager, as a Catalyst Manager. And then we have got vBond. Now they have renamed it as a Catalyst Validator. They have got one more controller called vSmart. Earlier we used to call it vSmart, but now they have renamed it as a Catalyst Controller. Catalyst Controller. So earlier they had V everywhere because the solution was from originally this solution came from Viptela. So what Viptela had was like every component was starting with V, whether it was a vSmart, so it was vSmart, then vManage, then it was vBond. And for routers, they had vEdge routers. So they had routers, vEdge, but now in Cisco, we have got cEdge for Cisco routers. We have got so many different platforms from Cisco nowadays supporting SD-WAN. I would say most of the Cisco platforms are supporting SD-WAN. I'll end this session today a little earlier. Yes.
I hope you get well soon. So, question comes to mind here. Any of these devices, I think these are like some software based, like a vSmart could be the appliance, right? All others are like cloud based.
None of them are appliances except vBond. vBond can be an appliance because it's a router.
Oh, okay.
It's a router, so it can be an appliance, but it is not recommended to keep it as appliance. You can simply have a virtual router and use it as a vBond. That is the only component that could be an appliance. But other than that, like vManage and vSmart, those are completely virtual devices, the software based. Either you need to get them hosted in cloud or maybe on top of some hypervisor such as ESXi or KVM.
Okay, as of this class, which one of these will be used in our class? Like
that's what I said. On-prem.
On-prem, okay.
Yep. So we're gonna deploy them on top of the ESXi. The labs that you would have access to, we are using the EVENG type of solution, right? I think it's EVENG or maybe some other stuff. I don't remember that exactly, but yeah, we are using kind of like EVENG type of solution, and you would be accessing lab using that solution only.
Cool.
So
thank you.
Although I'll be deploying vBond, vSmart, and vManage on top of the ESXi just to display you that how to get it deployed in case if required. So we would learn that how to deploy the OVF template. First, we will have to get them downloaded from the Cisco's website. So I will also tell you that how to get them downloaded. And then also I will teach you that how to get them hosted on top of the ESXi. But as far as you are concerned, you would have access to the EVENG where you do not require to deploy the controllers. Those are already deployed, but then you need to power them on. You need to power them on and then get them set up. Anybody else, please? No? Okay, cool. So thank you all for joining today's session, and tomorrow we're going to start at same time. Cisco does not only call it just SD-WAN, they call it Secure SD-WAN. And there's a reason behind that because they have got so many different security features supported by the SD-WAN devices. So you can also apply the security as and when required. Like yesterday we saw that it was having a support for URL filtering, advanced malware protection, and IPS. All those features are supported by the Cisco SD-WAN, and that's what makes it Secure SD-WAN. The agenda, I have already discussed that yesterday, so I will simply bypass that. These are the labs. So you already should have access to these PPTs. These PPTs are uploaded to each one of your portal, the training portal. So you can access these PPTs from there. And we have also mentioned that which all labs we are going to cover or we are going to perform during the training, right? So these all are the labs. So in total, if you see, we have got like around 51 labs, and that's what we are going to perform during this training. This is the lab environment, and this is applicable for you as well. Like you will have access to this lab. This is how the lab will look like. So in this lab, you can easily see that there is a data center in left side, left top. There's a DC. In DC, we have got CS router. So it is a Cisco Edge router. It's not a virtualized router. I'm not calling it VH. I'm calling it CH. It's a standalone CH. And in DC, you are also going to host your control components. And for control components, you have got this subnet 100.4.1.0/24. Out of which .1 will be allocated on vManage, .2 will be allocated on vSmart, then .3 will be allocated on vMont. And .100 is configured on the gateway, which is this firewall. In reality, in this lab, it is not a firewall. It is a router, right? This is how the controllers will be hosted, and then they all have got the management interfaces as well. So each controller is also having the management interface. So management interface will have an IP address from the different subnet. Although in this diagram it's 192.168.1.0/24, that's the management subnet. But in real lab it's not the subnet. The subnet has got changed now. Earlier we used to have the subnet, but now we have changed it. There are two providers. One of them is internet service provider. The other one is MPLS provider. So like in DC, internet is terminating on this router. It's a non-SD-WAN router, and similarly MPLS connection is also terminating on same router. Then there's a single connection that goes towards CS. So this router is going to work as edge router. So indirectly this edge router is having access to your internet as well as to the MPLS network. Then you can also see that we have got a few remote sites like site 1 at right top. You can see that this is site 1, and then after that we have got site 2. And the major difference between site 1 and 2 is that site 1 is dual CPE. So when I say dual CPE, which means that they have got dual managed routers, and that's what exactly you could see here. We have got dual managed router. Then site 2 is also there, and it's a single CPE site, which means that you have got a single managed router. And then site 3 is also there, which is again dual CPE. But site 3 is designed to configure the DLOC extension that we will cover later on, right? So for now, I'm not really focusing on DLOC extension. I'm just explaining you the topology. So this is how this topology has been constructed, has been created. So in total, you have got like 4 sites, including data center. So there's a data center, there's a remote site 1, 2, and 3. There are 2 different types of providers. One of them is internet service provider, the other one is MPLS provider. So this is how this lab looks like. Routers at the remote sites also having including data center, also having some loopback interfaces. So you can simply take a look at here. And so the SD-WAN solution overview, we'll talk about that. Basically, yesterday we already had a discussion that the traditional WAN, like you had MPLS connectivity, you had internet connectivity. So for internet, you had an IPsec tunnel that you used to configure on each router individually. Whenever you needed some modification to your IPsec tunnel, you needed to go to each router manually and then to make those modifications manually. Why? Because each router had its own management plane, its own control plane, and its own data plane, right? So that's how the routers were behaving, right? Now things are changing, right? Why? Because users have got more requirements. How? Like more and more applications are moving to cloud, right? Like you're utilizing them as software as service. But then you also have a concept of infrastructure as service, in which you basically create your infra inside the cloud itself, like inside AWS cloud or Azure cloud or GCP, right? Wherever you want to build your infra, you can build your infra where you keep your services running in that infra. So infrastructure as service is also there, and then the remote sites would require direct internet access to have access to those SaaS-based applications directly, right? So you need DIA, direct internet access, and also users wants to have access to the resources from anywhere, anytime. That is also something that we need to meet, right? I mean, that is also another requirement. So obviously, traditional WAN was complex to operate, difficult to secure, and poor user experience that we had for the end users. So security challenges were there. Like obviously to secure your communication over the internet, you always needed to establish an IPsec tunnel manually. Limited app awareness was there, right? So like we never did application routing on the routers because they had routers had limited app awareness. No cloud app readiness. Like there was no concept of like if you talk about the traditional WAN where you had your normal Cisco routers. So those routers never had readiness for the cloud applications like your SaaS-based applications, for example, Office 365, Salesforce, or the cost was high, as I told you yesterday. The MPLS cost was really high, and it was complex to operate that network. Right, you needed more people to handle your network, right? And then also at the same time you had insufficient bandwidth because with MPLS, you, as I told you, like you might have a geolocation where service provider had some limitation for the MPLS bandwidth, such as 10 Mbps or 20 Mbps or something like that. So that was the problem. These are the challenges that we had, and even we discussed them yesterday. And then SDN was introduced, software defined networking, right? So in SDN, basically you get a controller, and from that controller you try to push your configuration from a centralized location, right? And that's where exactly Cisco SD-WAN lies, right? So SD-WAN is a component of the SDN. As I told you yesterday, that when it comes to the software defined networking, even within Cisco, we have got so many different things or different products, like SD-WAN is there, then SDA is there, ACI is. So we have got like so many different things within Cisco itself, right? Under SDN, software defined networking. And therefore I'll call this Cisco SD-WAN as a single component of SDN, software defined networking. Now, as I told you yesterday that from today onward, we're going to start like with the architecture of the Cisco SD-WAN. So if you look at the architecture of the SD-WAN, so let me just pull out the architecture. So this is the architecture of SD-WAN. So if you look at the architecture, so we have got the control components, and then we have got the managed routers that will participate or that would be participating in data plane of your network. Let me use a big pen here. If you look at here under control components, like these all are the control components in SD-WAN architecture, right? You have got vBond, you have got vManage, you have got vSmart. Although now Cisco has renamed all these components, and I will also discuss them with you that what we call them now. But like for a long time, for a long period of time, there was a vManage, there was a vSmart, there was a vBond. These are the terminologies that we used it for a long period of time. And therefore, even today, you would see that most of the engineers are using the same terminology for all these components, although Cisco has renamed them. So under control components, you have got vManage. So this vManage comes under the management plane. Okay. And this vBond, which is also known as orchestrator, that comes under orchestration plane. And then you have got a control plane where the vSmart controllers will lie. So these vSmart controllers will be under the control plane, or will be working as a control plane of your network architecture in SD-WAN. So in Cisco SD-WAN, you have got control components, and you have got different control components for different functionality or for different functions. So, for management, like in Cisco SD-WAN, you would always have GUI access to your vManage. So you will always log in onto vManage using GUI, graphical user interface. You will log in onto the vManage, right? And then after, you would be working on your network infrastructure from there only. So as an admin, what important for us is to have access to the vManage using GUI. So if you are sitting on your laptop or maybe on desktop, you just have to have access to the vManage using your browser. You will be getting admin credentials or the user credentials, right? So using the provided user credentials, you will log in onto vManage, and then you will start working on your infrastructure, right? So basically, from the admin user perspective, the important thing is to have access to the vManage. So if you have access to vManage, you can do whatever you want to perform. If you lose access to vManage, you will not be able to perform anything in your infrastructure. Yes, you can also log in onto your routers locally. So if you have got the managed routers, you can still have access to them using either console, or you can have access to those routers using SSH, or maybe if you have enabled the telnet. Telnet is not supported anymore, so you would always have access to your routers using SSH. But again, it will be depending upon that how you have configured your routers. So in most cases, routers will not allow you to make the changes through the CLI, right? Because you are managing all these routers from this vManage. So you should always have access to this vManage. So this is management plane. Right? So you should have access to the vManage so that you can manage your entire network infrastructure. So if you want to make any configuration changes onto managed routers, you want to perform some troubleshooting, you want to perform some monitoring, everything will be done on vManage. That's the management plane. And remember that it is always a critical component from the admin perspective, because if you lose access to vManage, you would not be able to perform anything onto any of your component. So, and therefore, even Cisco is providing you an option to configure your vManages in a single cluster. So you can create a cluster where you can have like 3 or more vManages. So just in case if one of the vManage goes down, the other vManages are there to serve the admin access. So we should always create a cluster of the vManage in production environment. So management plane is vManage, and then you have got this orchestration plane, which is also known as vBond. You can also call it orchestrator. So this vBond is your orchestrator, and again, it is also one of the critical component here in this entire architecture. So if you look at here, basically Cisco is following the distributed architecture here, right? So these all are the control components: the vManage, vBond, and of course the vSmart controller. So all together, all these components are working as a control components here. So that's that's working as a brain of your SD-WAN architecture. You can see that, right? It's like a brain. vAnalytics is not a mandatory component. It's not it's not much needed. But yes, it's an optional thing, optional component that if you want to subscribe to the vAnalytics. The only purpose of the vAnalytics is to provide you attractive reports, right? So if you want to generate reports of your network infrastructure, like what is the bandwidth uses for a specific branch, or maybe if you want to see that which all applications are most accessible by the end users, right? So all those sort of reports can be generated from vAnalytics. So for generating reports, you have got that tool vAnalytics. So it is not a mandatory component here in SD-WAN architecture. So that works based on optional mechanism, right? So if you want to subscribe the vAnalytics, you can subscribe that. If you don't want, you can leave that. You can skip the vAnalytics. But vManage, vSmart, and vBond, those are not optional. None of them is optional. All are required to work together as a brain of your architecture. So you have got vManage, vBond, and vSmart. These are the three main components. Now, if you compare this architecture with some other SD-WAN providers, right, or vendors like Silverpeak, or maybe you want to compare this with the Velo Cloud, they all have got, like, most of them have got a single control component that works as a management plane, that also works as an orchestration plane, and also works as a control. So they all have got like a single component working as management plane, orchestration plane, as well as control plane. Now, with that, I would say that for other vendors it is a kind of single point of failure. Why? Because if one component goes down, then you lose everything, right? You lose your management plane, you lose your orchestration plane, you also lose access to your control plane. So all these components will go down if you are using a single one component for everything. But as I told you, that Cisco is using distributed architecture, so it's a distributed architecture, right? So the brain is splitted. The brain of this SD-WAN architecture is splitted into multiple components, right? So like vBond is there, vManage, vSmart. Now remember, if we talk about the vManage or vSmart, these are not hardware devices. These are the virtual machines. Now you can host these virtual machines either in cloud. I mean, it's up to you. If you want to host them in cloud, you can host them. If you want to host them on-prem, like on top of ESXi hypervisor, or maybe KVM hypervisor, you can do that. We just have to download the images for vManage and vSmart controllers, and then we can get them hosted virtually. When it comes to the vBond is a router actually. It's a VANEDGE router. It's not a different device. It's a VANEDGE router, and therefore the VANEDGE router can be a hardware and also it can be a virtual. Why? Because the virtual routers are also available. Not only hardware routers, but also virtual routers are available. So you can have a virtual router hosted either in cloud or maybe on-prem on top of ESXi or KVM. And then you can use it as a vBond. Basically, there is a single command that you need to run on a router to make it a vBond. So vBond is not a separate device. It doesn't have a different operating system. However, when you talk about vManage has got a different operating system, right? And then same, vSmart has got a different operating system, right? It is a different component altogether. But vBond is similar to VANEDGE router, and therefore vBond could be a hardware. It could also be a software or virtual device. Whereas vManage and vSmart, these two components are always going to be a virtual component. Okay, so the brain of the Cisco SD-WAN is this vManage. So altogether, these components, vManage, vBond, and vSmart, working as a brain for this architecture. And then in data plane, you can see you have got routers. So routers you can place in data center, routers you can place in campus infra, routers you can place in branches, and also routers you can place for SOHO, small office, home office. Like for higher authorities, in most cases, they work from home.
Excuse me, sir. I have
Uh-huh.
a question here.
Uh-huh.
So we've got the purpose of vManage is like a management control plane or a
Correct.
management tool.
Mhm.
And what's the purpose and use of vBond and vSmart
I'll
controllers?
come to that point as well, right? I'll come to that point as well. But for now, I
Okay.
was just trying to make you understand the architecture here, and then I will just cover them individually.
Okay.
Okay. Now, one more thing that you need to understand, that vManage is also supporting the APIs. It supports REST API, right? It supports REST so that you can perform the third-party automation, such as I'll just give you one example. So let's say you have got ServiceNow, and ServiceNow you are using for ticketing purposes. You want to integrate vManage with ServiceNow so that based on some specific events, right, you want to generate some ticket on the ServiceNow, and you want ServiceNow to assign that ticket to a specific team or DL, distributed list, right, that you have created for your entire team, right? So you want to integrate ServiceNow with vManage, which is a ticketing tool, right? So you can do that using the REST API. So that's the reason for supporting the REST API by the vManage, right? So you can easily integrate your vManage with some third-party applications for the purpose of automation. So I just gave you one example that REST API could be required to integrate your service now with this vManage, right? So there could be various different reasons, various different requirements where you may have to use the REST API to perform the integration between third-party application and the vManage. So remember that REST API is supported by the vManage, and vManage is collecting all the data from all other components. So if anything happens on any other component, that information is always given to the vManage. Therefore, if you just perform the integration between your third-party application and the vManage, that is more than sufficient. And that is the only reason that REST API is supported by the vManage only, not by any other component. I'll go back a little. So if you look at here, the Cisco SD-WAN, as I told you, the routers in Cisco SD-WAN could be physical or virtual, right? So that's another advantage over here. The redundant management, right, which means that you can have your management plane on-prem, which means, as I told you, the vManage can be hosted on-prem, or you could host your vManage in cloud, right? Or maybe at both places for the purpose of redundancy. Zero-touch provisioning is supported by Cisco SD-WAN. The meaning of the zero-touch provisioning is that, let's say there is a remote branch that you need to bring up now. So the meaning of zero-touch provisioning would be like you would have your field engineer to bring the router to that location and to unbox the router, install router in the rack, make the cable connections and power it on. And that's it. You don't want your field engineer to take the console access of the router. No, you don't want that. You just plug the internet circuit, you just plug all the required cables on that router, power it on, and that's it. And that's called zero touch provisioning. So that type of zero touch provisioning is supported by Cisco SD-WAN. Now, how that works, that's something that you would understand as we go further. But zero touch provisioning is supported by Cisco SD-WAN. Now, the separation of the management control and data for scaling purposes. Yes, this is what exactly Cisco has done here, right? In this software defined wide area network, right? SD-WAN. So what they have done is that they have got a separate management plane, they have got a separate control plane, and then of course they have got a separate data plane. Like earlier, traditionally on a single router, we had everything. Router was having its management plane, local control plane, as well as local data plane. But now in SD-WAN, Cisco has got a centralized management plane, a centralized control plane, and then of course the data plane does exist everywhere across all the routers. So all routers will have their own data plane. But yes, the separation of management plane, control plane, and data plane for scaling. The topology, you can always change that. As I told you even yesterday, that the default behavior of the Cisco SD-WAN is to provide you full mesh connectivity between the remote sites and the data center. So by default, there is a full mesh topology. But again, you can modify that. And if you want to modify the topology, it's a matter of point and click. Like you just go make some clicks, and then you would simply change it from, let's say, full mesh to hub and spoke. So it's so easy to change the topology. From full mesh, you can make it to hub and spoke. You can make it partial mesh, whichever type of topology you want to use, you can use that. Flexible connectivity with any WAN technology. So as I told you even yesterday, that not only internet connections you can use with SD-WAN, but also you can use the MPLS. So not only MPLS, but also 4G, 5G, right? These wireless networks can also be utilized by the SD-WAN. Cisco SD-WAN technology. So for WAN connectivity, you can have dependency on any type of connection. Like as I gave you a couple of examples, internet. And of course, for internet, you have got two different choices. One is broadband, the other one is internet lace line, and that is again wired or wireless. You can use any of them, and also you can use the Metro Ethernet type of connection, like kind of MPLS, right? So any WAN technology is supported here with the Cisco SD-WAN. Although, like being a SD-WAN provider, like let's say if I'm representing Cisco in front of customers, I would request customer to remove the MPLS and just focus only on the internet. I would request to the customer to reduce their recurring cost, because MPLS bandwidth is much more expensive than the internet one. But let me tell you one more thing. There are few countries across the globe, across the world, right, or in this universe, where MPLS is much way cheaper than internet, because they have got like expensive internet, right? But they have got like cheap MPLS type of connection or private connectivity, right? So that can also happen, but that is applicable only for few countries, not in many countries. Okay, the segmentation is also supported by the help of VPN or VRF. So Viptela used to call it VPN, but in Cisco we call it VRF, right? So the meaning of VPN and VRF is same, right? It's a VRF, right? That we use for the purpose of segmentation. So when I say VPN, don't think of site-to-site VPN or remote access VPN. Those are different terminology. Here I'm just talking about the VPN only, right? It's a VPN terminology, just VPN. It's not an IPsec or lane-to-lane VPN. No, it's just VPN. So VPN and VRF is the same thing. Then single pane of glass. So as I told you that the vManage, right? You have a complete visibility to your entire infra from vManage. So vManage is working as a single pane of glass, right? And then critical traffic redirection with application aware routing. So if you have got, let's say, requirement that for a specific application, let's say for HTTP or maybe for HTTPS or maybe for FTP or for DNS traffic, you want to redirect your traffic through a specific interface, you can do that, right? So application aware routing is also supported by the routers in Cisco SD-WAN. And then you have got a secure data plane connectivity as well as control plane connections between the devices. So as I told you that the tunnels, IPsec tunnels in data plane will come up between the remote site routers automatically. So you don't really have to make that lengthy configuration for bringing up the IPsec tunnel between the remote sites that we were doing in past. Like if you remember, if any of you have already worked on IPsec tunnels, then you must remember that we used to configure like phase 1, phase 2, and on top of that, even sometimes you were configuring IKE v2, right? So if you were working on IKE version 2, then you were defining like policies, proposal, and then you were combining them into a crypto map, and then you were applying that crypto map onto your interfaces, or maybe you were implementing DMVPN, right? But in all cases, you needed a lot of manual configuration, right? But here in Cisco SD-WAN, the first thing is first that the data plane connectivity, the IPsec tunnel between remote sites comes up automatically. You don't do anything for that, right? You don't make any phase 1 configuration, phase 2 configuration. Even the pre-shared key is getting exchanged automatically between the remote sites. You don't configure any pre-shared key there. And not only data plane connectivity is secure, but also the control plane connection is secured using DTLS tunnel. So in SD-WAN, there will be use of the DTLS as well. So we will see the use of DTLS tunnels. The Cisco SD-WAN is cloud readiness, right? It is having it is ready to adopt the cloud. Why? Because with Cisco SD-WAN, you can integrate your SD-WAN infra with the cloud infrastructure, right? Whether it is IaaS, infrastructure as service, or maybe if you want to integrate your Cisco SD-WAN with SaaS-based applications like Office 365 or Dropbox or Salesforce, you can do that. So your routers are ready to adopt the cloud technologies. And then you have got a separate, or I would say a Cisco proprietary protocol for overlay routing that is called OMP, Overlay Management Protocol, right? So they have got a dedicated protocol, Overlay Management Protocol, and this OMP routing protocol is totally different routing protocol than what we have learned so far, like BGP, AGRP, OSPF, ISIS. It's totally different than those protocols. And this OMP, Overlay Management Protocol, is a Cisco proprietary protocol, okay? So that's something that you should always keep in your mind. I'll go back here, and now since we are going through this architecture, let's start talking about each component individually. Like I spoke about the management plane, which is also known as vManage. So as I told you, vManage is a single pane of glass for day 0, day 1, day 2 operations. Right? So whatever you want to perform in your architecture, in Cisco SD-WAN architecture, you will be doing it from the vManage. Whether you are doing monitoring, you are performing troubleshooting, you are making configurations. Everything will be done from the vManage. So as I told you before, the admin should have access to the vManage, GUI access to the vManage. So like in browser, when you put the IP address of the vManage, then you have access to the vManage. You log in onto vManage and do everything. You do monitoring, troubleshooting, even the traffic capture can be taken now. I believe Cisco has added that feature as well. But in nutshell, you must have access to the vManage. The admins, all admins must have access to the vManage, and everything will be done from this vManage. And in fact, as we move forward, right, and we deploy the vManage, you would see that how we are working from the vManage. So all the configuration templates, all the policies, whether those are control policies or data plane policies or security policies or the integration with cloud, everything will be done from the vManage. The multi-tenancy is also supported by the vManage. And mainly this feature was added by Cisco for MSPs. So when I say MSP stands for Managed Service Providers. So if there is an organization who is providing managed services, right? So for an example, Tata is providing managed services to their customers. Then Airtel is also providing managed services. So if there are companies providing managed services to their customers, sometimes they may have a situation where they have got like small customers having, let's say 10 sites, 5 sites, 20 sites, and they are not enough capable to pay the money for dedicated control components, right? Like if you want to host dedicated control components for that customer, obviously there will be some charges applied, right? So if the customer doesn't have that much budget to spend on the control components, right, then they can opt the multi-tenancy as well. Like MSPs can offer the multi-tenancy. Like they can ask customer, right, that would it be possible for you to utilize the shared vManage? So if they agree on that, then you can have your customers deployed in multi-tenancy. So in that case, you will utilize a single vManage for multiple customers. Then vManage will also support the centralized provisioning. The meaning of centralized provisioning is that from a central location, you are going to provision everything, right, in SD-WAN architecture, right? You are going to create policies, configuration templates from vManage. You are going to perform troubleshooting and monitoring from vManage. You want to perform the software upgrades for any component, you do it from vManage. On top of that, you also have a support for the RBAC. RBAC stands for Role-Based Access Control. Role-Based Access Control. So what you can do, let's say you have got a team where like a team is a blend of some blend of multiple engineers having multiple or different capabilities. For an example, the team is having a couple of engineers having an experience in between 1 to 3 years, and also having engineers having experience between 3 to 6 years, and maybe more than that. So now, based on their experience and roles and responsibility within the organization, you want to provide them different level of access to the vManage. Like there's a team which I just want to provide access for the monitoring purposes. I don't want that team to make any changes to the infra, but I just want to provide them access to the vManage for the purpose of monitoring. It's kind of read-only access, right? So I can do that. So I can tell the, hey, this user group should have only should have read-only access to the vManage. And then the other group of admins should have access to modify the policies and templates, but not the security policies. So you can also do that. And then there is another group of admins which you want to provide the full access. So you can always do that. So this is called role-based access control, right? And it is supported by the vManage, right? So you can do that. Then, as I told you before, that it is going to have a support for the REST API if you want to perform any kind of integration with some third-party tools or applications such as ServiceNow or maybe some other stuff. There are many other applications out there in the market, right, for different purposes, whether those applications are for ticketing or maybe even for monitoring. So you can perform that integration with REST API. The netconf, right? So in Cisco SD-WAN, what Cisco did is that they have completely replaced SNMP with netconf. As you must be knowing, all of you must be knowing that netconf is an advanced version of SNMP. So remember, in Cisco architecture, in Cisco SD-WAN architecture, they have completely removed SNMP. They all are going to use netconf. Like as I told you before, that you would be doing everything from the vmanage. That means that from vmanage you would be pushing some information onto your routers, and at the same time you will also be pulling the information from the manage router, and not only from the to and from the manage router. The same applies to vsmarts and same applies to the vbond. So vmanage needs to talk to each of these component, right? To each and every component. That requires some sort of communication, right? So ideally for this purpose, we were using SNMP in past. Even today, if you find like maybe SolarWind or some other applications, QRadar and so on, so they are still using SNMP. You can see that in your infrastructures, right? If you are working somewhere, you can see that people are still using SNMP. But remember that netconf is an advanced version of the SNMP, and it is more secure than SNMP. So what Cisco did is that instead of using SNMP for this communication between vmanage and the other component, they are using netconf. Now, it does not mean that SNMP is not supported by these SD-WAN components anymore. No. Let's say that you are having QRadar or SolarWind and you want to integrate that with your routers here in Cisco SD-WAN architecture. You can still do that. When you configure the templates from vmanage onto your managed routers, within template, you get an option to configure the SNMP communities as well, right? So that you can integrate your routers with some third-party applications like QRadar or SolarWind monitoring system. So that is still supported. So SNMP can be configured, but internally vmanage will be using only netconf. So that's the use of netconf. So by default, netconf is enabled on vmanage, vsmart, and the managed router. And therefore, they all can talk to each other using netconf. So if vmanage required to pull some information from any other component, or maybe to push any information to the other components, then it will be done. It will be done by the help of netconf. Highly resilient, that statement. So remember that across all the Viptela components, like its vbond, vmanage, vsmart, all these Viptela components are using Linux based operating system. The kernel is Linux, right, for all these components. And you must be knowing that if the operating system is a Linux based operating system, then you call it highly resilient operating system. So that's what make it highly resilient. So that's about the vmanage. The next component is vsmart, right? As I told you, vsmart is a control plane. Like it will work as a control plane in the overlay network, right? In Cisco SD-WAN architecture. So in this Cisco SD-WAN architecture, you have offloaded the control plane functionality from WAN edge router, and now you have a centralized control plane in form of vSmart controller. So earlier we had control plane available across the routers. Like each router had its own control plane. Now, when I say that we have offloaded the control plane functionality from WAN edge router to the centralized vSmart controllers, it does not mean that now you can pull out the main CPU from each of these routers. No, you cannot, because the control plane is still needed on these WAN edge routers. It does not mean that you have completely removed the control plane. You offloaded the control plane, but only from OMP perspective. The control plane for OMP has been offloaded from WAN edge router to the vSmart controllers. Now, for an example, if you're running BGP on a WAN edge router, now the control plane of the BGP is still running on that router locally. So you cannot pull out the main CPU. You can't say that no, there is no control plane required anymore on the WAN edge router. No, that's not true. But yes, you have offloaded that, in respect to the OMP only. There is a protocol called OMP that works in overlay, right? That helps to exchange routes between the remote sites via vSmart controller, right? So obviously in that respect, you have got a centralized control plane onto the vSmart controllers, right? So vSmart controllers are going to work as a control plane, but in respect to the OMP only. So when we say that control plane has been offloaded, the control plane functionality has been offloaded from WAN edge router to the vSmart. It does not mean that the complete, the control plane was removed from the routers completely or was offloaded completely. No, that's not a true state. But yes, in regards with OMP, the control plane functionality has been offloaded to the vSmart controller. Now, what is the advantage of having the centralized control plane? First thing is first, if you are having a centralized control plane, then you must not be having a single vSmart at any cost. You must not be having a single vSmart. Why? Because if you have a single vSmart, then you have a single point of failure, right? And you don't want to have the single point of failure at any cost, right? So it is always recommended that you should have at least two different vSmart controllers, which means two different control planes here. So you need at least two vSmart controllers in any deployment. That's first thing. Second, you can have more than two as well, like 3, 4, 5, 6. It's up to you, right? You can also have the different set of control planes or different set of vSmart controllers for different regions. Like maybe for EMEA, you can have a different set of vSmart controllers. For APAC, right? And then for AMER region, you can have a different set of vSmart controllers. So that's doable. But at least you should have two vSmart controllers. Now remember, since vSmart controllers are working as a control plane, which means that for OMP, because OMP is also a routing protocol, is it is also a routing protocol. So remember that OMP is not just a routing protocol, it also does so many other things, right? So that's why the full form, or the OMP stands for overlay management protocol, right? We don't call it overlay routing protocol, we call it overlay management because it's managing the overall overlay network, right? That's the reason that we call it overlay management protocol. So it does not only perform routing, but also the vSmart controllers will have the OMP database, and once they have the OMP database, they can also select the best path, and then they can advertise that best path information to the managed routers, right? So point is that vSmart controllers are going to have the control plane database and will have responsibility to select the best path and to provide that best path information to the managed router, right? So that all stuff will be done by the vSmart controllers. Now, since vSmart controllers are centralized control plane, right? So for an example, for a managed router, like you have got 500 remote sites or maybe 1000 remote sites, right? And you needed to switch your preferred WAN link from Tata to Airtel or vice versa, whatever, right? From Airtel to Tata or Tata to Airtel. You had a requirement. Like yesterday, I discussed about that specific situation, right? Where let's say you had Tata, Airtel was your primary, then you wanted to make Tata as primary or vice versa, whatever, right? If you have same requirement over here in SD-WAN, then you just have to modify the policy on vSmart controller. So you are modifying the policy only on vSmart controller at once, and then it can affect all 500 remote sites at same time. So like you still have the same requirement, the same task, the same goal, but this time you did it in just a couple of minutes, right? Because you modified the policy on your centralized control plane, right? And then it affected the decision, right, of all 500 remote site routers. So
So,
that's hmm.
is there any kind of priority to define
uh,
on link?
So I will not dive into that kind of communication as of now. Why? Because like if you remember BGP, right? So in BGP you had different parameters that you could utilize,
Attributes. Yeah.
right? That you could utilize for the purpose of best path selection. In similar way, the OMP has got different parameters, right? Which you could leverage to modify the path selection, right? And I'm not moving into that kind of discussion as of now. All I just wanted to tell you is that you can modify the policy on vSmart, and you could modify the path selection for all 500 remote sites at once. So it has simply reduced the control plane complexity. Why? Earlier, each router had its local control plane, right? And then if you needed to make certain changes, you needed to go to each and every router individually and you needed to make those changes. But now in SD-WAN, you have got a centralized control plane. So you modify your change, you apply your changes here on these centralized control plane, and then it would affect all of your routers at once, right? So it has simply reduced the control plane complexity, right? Highly resilient. Why? Because again, the vSmart is using a Linux based operating system, right? Now remember that on vSmart you can simply create, the vSmart will be responsible to implement the control plane policy, which means that if you want to filter routes, or maybe you want to perform path selection manipulation, you can do that. You can change your topology, because ultimately when you change your topology, which means you are doing some sort of filtering, right? Like kind of route filtering, or maybe you are stopping your managed routers to establish the IPsec tunnel between each other, right? So you would have different components, you know different component to filter. Like you can filter routes, you can filter T-locks. There is a terminology called T-lock, transport locator, that I'll discuss later on, but those filtering can be done on the vSmart controller to modify the topology.
So
Now,
would you be, sorry to interrupt, would you be discussing this, like if there is any topology change happening on any branch sites or a data center site or wherever it is, how this be cascaded to the other branch sites?
that is part of the policies, right? So once we start the policy section, then you would see that how the policy change is affecting all the remote sites. Okay.
Okay, so you can explain the flow, right? How that is happening?
Not now.
Oh, yeah, yeah, later means.
Obviously, you have
Yeah,
everything to cover, right? As of now, we are just going through the description of each
sure,
and
sure.
every component so that we understand that what is the role and responsibility of vManage, and
Yeah.
roles and
And one,
responsibility of the vSmart and the vBond then. Hmm.
yeah, and one question on, you said that we manage monitoring and all through the net count. We do not manage anything here based on the SNMP. But generally, the in the enterprises, everyone will have some monitoring tools, SolarWinds or
That's why
anything
I
else.
said I also made the same statement, if you remember, that internally vManage is using netconf to talk to each and every other component, correct?
Mhm.
But
Mhm.
every component has got a support for SNMP as well. So if you have a requirement to integrate your other monitoring tools like SolarWind or QRadar, the
Okay, we can
SNMP
do
is
so.
still there. You can apply the
Okay,
SNMP community for that purpose. I also
okay,
made that statement.
okay. Sorry, I missed that. Thank you.
Yeah, no problem. So disseminate a control plane information between managed route. This is very important and critical statement. If there is a route in data center and we need to take that through the campus or maybe branch sites, all the routes will get exchanged between remote sites, including data center, via vSmart only. You know, there is a protocol that runs in between vSmart and the managed router, and that protocol known as OMP, right? So OMP neighborship will come up between vSmart and the managed router. Once this OMP neighborship comes up, then data center router or any managed router would provide OMP updates to the vSmart, and vSmart can provide OMP updates to the managed router. In form of OMP updates, they will exchange their routes information, the lane prefixes. So let's say DC has got lane prefixes, the campus has got lane prefixes, the branch have got some lane prefixes. So each and every router would provide or would be responsible to provide the lane prefix information to the vSmart controllers in the form of OMP updates only. Does that make sense? And that's how the vSmart would have a complete control plane database, or a complete control plane information, right? Then vSmart will be responsible to select the best path and then to provide that information to the OMP peers, right? So let's say one information came from Soho, right, to the vSmart. Then vSmart would be responsible to flow that information or to float that information across all other OMP peers, right? So the default behavior of the vSmart is quite similar to what route reflectors does in BGP, RR in BGP, route reflectors in BGP. So I don't know how many of you are familiar with the route reflectors in BGP, but this vSmart has got exactly same, I would say, functionality as route reflectors does in BGP, right? So the vSmart would receive the OMP update from managed router, and ideally, as part of the OMP update, they will receive the lane prefixes. then the responsibility would be to select the best path and to provide that best path information to all other OMP peers. So the control plane information, which means the route information, will get exchanged between the managed routers via vSmart, right? There is no way, like let me tell you one thing here, that if you have got a campus router, right, and if you want your campus router to exchange the route with branch router, then there is no way to exchange that control plane information directly between the routers. There is no way for that, right? This is not how Cisco SD-WAN works, right? In Cisco SD-WAN, if any router, right, if two different sites wants to exchange routes information, then they must exchange route information via vSmart. That's the only way we have got in Cisco SD-WAN to exchange the control plane information between the routers, managed routers. Does that make sense?
Okay, but at the data plane level, the WAN edge routers would be maintaining certain route table
Tunnels.
databases.
I mean, that is about the managed router. I'll start discussing about the managed router on the very next slide. But
Sure.
for now, I hope that now you're good with the vSmart controllers, right?
Yeah.
That
Yeah.
control plane, right? It is working as a control plane. We have offloaded the control plane functionality from the managed router to the centralized control plane, vSmart controllers, right? But also at same time, I made this statement that it does not mean that you have completely offloaded the control plane. As I told you that let's say you are running OSPF here, right, in lane side or maybe BGP, you can do that. So who is controlling this OSPF and BGP on this router? That's the control plane. So that has not been offloaded to here, right? The control plane from OMP perspective was offloaded to the vSmart. The OMP database will be maintained by the vSmart controller. The OMP path selection will be done by the vSmart controller, right? So it is a control plane from OMP perspective. All right. The next thing that you should be knowing is the orchestration plane, which is also known as the vBond, right? So this vBond is your orchestration plane. And you can simply compare this orchestration plane as Naukri.com here in India, right? Naukri.com or maybe LinkedIn,
Hi, Sarah.
right?
Sorry if I may ask.
hmm
What about the communication protocol between the vManage and the vSmart controllers?
The netconf. So as I told you that, netconf is the protocol that would be utilized by vManage to talk to, each and every other component here in this architecture. The netconf would be running inside a secure tunnel, which is also
Okay,
known
okay.
as the TLS tunnel.
So the OMP is running just between the vSmart
vSmart and the
controllers.
managed router. Yep.
Okay, got it. Thank
Yeah,
you.
I will come to that point as well because I still have to cover the managed router, and that's where I'll mention this that OMP pairing will come up between them. The Cisco vBond, right, also known as orchestration plane or orchestrator, and you can simply compare this with Naukri.com in India. I don't know how many of you are using Naukri.com, maybe LinkedIn, or you can, there are many websites for the job seek. So what happens is like on Naukri.com, like if somebody is looking for the job, they come and they get themselves registered over there, right? They upload all their information on the Naukri.com. And if somebody is looking to hire an employee, they also come and have access to the Naukri.com portal and they look at that, okay, which all people are looking for the job. And if someone is suitable to their profile, they simply call them up, right? And then once they make the call, then they can directly talk to each other, right? Now there is no point of or there is no role of Naukri.com anymore, right? But initially they communicated to each other via this platform. So this is how exactly this orchestration plane or vBond is playing its role here in this architecture. So thing is that this managed router cannot talk to vSmart or vManage directly. There is no point or there is no way that managed router could directly communicate with vManage or vSmart directly. No. You know what happens is before you onboard or before you deploy the managed router, you must deploy all your control components. Once you deploy your control components, then what happens is that vManage will have a permanent connection with vBond. At same time, vSmart will also have a permanent connection with the vBond. And that's how the vBond has a controller list now. It has a what? controller list. It knows that which all vManages we have got here, which all vSmarts we have got here, right? It is maintaining a complete controller list. Okay. And then we go to manage router. On manage router, we tell that, hey, this is the vBond IP address. Therefore, this manage router will go to vBond. And now, if vBond authorized this router successfully, let's assume that it was a valid router to this organization. So vBond will authorize this router successfully, and then after, vBond will provide this entire controller list to this manage router, so that this router now can initiate a connection to the vManage and also can initiate a communication to the vSmart controllers.